Today we are going to discuss the derivation of the ideal gas equation. So the derivation of ideal gas equation derive చేస్తున్నాం. So you already well familiar with the ideal gas equation is equal to PV is equal to nRT. What is the ideal gas equation? So if one mole gas తీసుకున్నాం అనుకోండి, one mole gas తీసుకుంటే సేమ్ ఫార్ములా PV is equal to RT అనేటువంటి ఫార్ములా మనకు తెలుసు. మనకు ఈ ఫార్ములా మనకు బాగా గుర్తు తెలుసు. So we need to derive this equation. ఈ ఈక్వేషన్ మనం derive చేయాలనుకున్నాం. So for this one I am assuming that I am taking one of the container. So in this container I am taking 1 mole of gas. ఒక మోల్ ఉన్నటువంటి గ్యాస్ తీసుకున్నాను, 1 mole of gas తీసుకున్నాను. So which is having under pressure P1 and volume V1 and temperature T1. Temperature T1 ఉన్నటువంటి దాన్ని తీసుకున్నాను. So what I did, so I am changing the pressure I am change చేస్తున్నాను. So I am changing the pressure. By changing the pressure దీన్ని ఏం చేస్తున్నాను అంటే by changing the pressure ను మారుస్తూ pressure I am converted this volume from V1 to V. Volume V1 నుంచి కన్వర్ట్ చేశాను. So I changed, so it changed volume V1 to V1 నుంచి V కి వచ్చేసాను. So that means this process is done at the same constant temperature. From this process నేనేం చేశానంటే టెంపరేచర్ T1 kept constant, అన్నిటిని టెంపరేచర్ ను kept constant లో ఉంచేసాను. సో దెన్ I can draw the diagram for this one. ఏం చేశాను ఒకసారి డయాగ్రామ్ చేస్తున్నాను. సో ఇనిషియల్ కండిషన్ లో I taken this one 1 mole of gas ఉంది, the pressure వచ్చేసి P1 V1 ఉంది, temperature T1. So I changed the pressure P1 to P2 లెక్ మార్చేసాను. Then I am converted the volume V1 to V1 లెక్ V కి వచ్చేసింది. Again here is the substance, ఇక్కడ గ్యాస్ వచ్చేసింది. P1 నుంచి P2 కి వచ్చేసింది, వాల్యూమ్ V1 నుంచి V కి వచ్చేసింది, టెంపరేచర్ మీద V1 లేకే వచ్చేసింది టెంపరేచర్ అనేది. So in this process the temperature is the constant. Where the temperature is the constant, can we apply the Boyle's law? Boyle's law apply చేయొచ్చు కదా. As the temperature is constant, hence we can apply Boyle's law. Boyle's law ను మనం అప్లై చేయొచ్చు. Boyle's law అప్లై చేయండి. Boyle's law రెండు కండిషన్ లో అప్లై చేయండి. Boyle's law రెండు స్టేట్ లో ఉన్నట్లయితే we can apply the two. Boyle's law means P1 V1 is equal to P2 V2. This is the condition what we have in the Boyle's law in the two different states. But here is the P1 V1, but here is the P2 ఇలా ఉంది, but V2 is the V is there. So I am taking for the future application. So I am writing this equation in terms of V లో రాస్తున్నాను. So P1 V1 divided by P2. Let's assume equation 1. Let's assume equation 2. Let's keep it aside. So now what I did, I am taking the second state. So what I did in the previous state, I taken the P1 V1 and T1. This is the state of the gas. While I am changing the P1 to P2, I converted this gas as the P2 as V and divided by P. Temperature is the T1 is the temperature. But now in this case what I am doing is I am increasing the temperature. I am changing the temperature from T1 to another temperature T2. I am changed the temperature from T1 to T2. In this temperature I am converted the temperature from T1 to T2. In this case the volume of the temperature is converted to the V2. In this case the volume of the temperature is the V2, but I kept the pressure is the constant same. P2. I kept the pressure is the same pressure. So in this case what I did, I converted the V to V2 I converted, but what I did, pressure kept at constant. P2 is kept at constant. So as the pressure is the constant, shall we apply can we apply Charles law? Can I apply now? So as P2 is the constant, we can apply Charles law. we can apply the Charles law. Charles law we are applying in this case. What we are applying? Charles law we are applying. Charles law we are applying. So Charles law, what is saying in the two different cases? What is the Charles law?
Volume is directly proportional to temperature constant.
Yes. V1 by T1 is equal to V2 by T2. Where the two states of substance is there, we can directly apply V1 by T1 is equal to V2 by T2. Will please look on this diagram where V is equal to V1 is equal to V, T1 is equal to T1. So here is the V is equal to V2, T2 is equal to T2. Are you getting or not? This is the first state, this is the second state. In this process, we are applying the Charles law. Are you getting or not?
Yes, sir.
Now this is the general formula I written here. This is the general formula. This general formula I am applying our present condition. Now will you please apply this one where V divided by T1 is equal to V2 divided by T2 divided by T2. So in the previous case I derived the equation for V. We derived the equation for V. So once again we already know the V value. So once again recall the V value where it is P1 by V1 by P2. P1 by V1 by P2 is there. Just to substitute the V value by substituting V value substitute here, that is equal to P1 V1 by P2, P1 V1 by P2 into T2. T1 is there, already T1 is there. T1, that is equal to V2 by T2 is there. V2 by T2 is there. Now I am sending P2 this side. So P1 V1 by T1 is equal to P1 V1 by T1 is equal to P2 V2 by T2. P2 V2 by T2. So if it is coming P1 by V1 by T1, P2 by V2 by T2 will coming means we can conclude that P1 V1 PV divided by T must be some constant. So the experimental results is saying that the PV by T is some constant value. They are saying that the sum of the constant R. These values denoted with R, where R is equal to ideal gas constant. This is the ideal gas constant. Now I am sending this T this side. PV by T is equal to capital R we got. Then PV is equal to RT. This is only we need to prove. So we proved this one. But if we take the n mole of gas for this equation, only for 1 mole of gas, for 1 mole of gas this one. But if you take the n mole of gas is equal to PV is equal to small n RT. This is the formula for small n mole of gas is equal to, this is the PV is equal to nRT for n mole of gas. Now they may ask the question like this: what are the units for R? They may ask the question the universal gas constant units for R, units of R. So what is the universal gas constant units? So to give the units for universal gas constant, we need to bring the basic fundamental formula. PV is equal to, I am taking RT only. So I need R value, that is equal to PV by capital T. What is the PV? What does mean PV? PV means pressure, no? So now I am taking here a rough work I am doing. Pressure is equal to force by area. So now what is mean by V? V is nothing but length into length only. So length into all are length I am taking, because of length value is a length only, breadth value is a length only, height value also length only. So if you take this value, force by area is nothing but length into length only. No change, na? Hello?
Yes, sir.
So now I am multiplying this one. PV is equal to force by length into length into length into length into length 3. So 2 L's are cancelled. That is equal to force into length. Force into length is nothing but force into displacement. Force into displacement is nothing but work. Work is nothing but energy. Are you getting or not? So this is the, what is this units? This units is the joules. What is the temperature units are the Kelvin. So that is equal to joule per Kelvin. This is the units for ideal gas constant. Now if we go to the CGS units, what we written here is the SI units. This is the SI units. If we go to the CGS units, CGS units means R is equal to, here is the work units is equal to erg per degree Kelvin, erg per degree Kelvin. This is the units for. Otherwise we can take erg degree Celsius. Degree Celsius inverse. That is the CGS unit. Now they may ask the question for dimensional formula. So dimensional formula they will ask. Tell me the dimension. To write the dimensional formula, we need to bring from basic formula. R is equal to PV by T. This is the formula. So if you want to write, this is nothing but work or energy only. This energy by T. T is the temperature. Energy dimensional formula. Anybody? Energy dimension formula. Otherwise if you go to the, otherwise work is equal to force into length. Force is equal to MA into length. MA is equal to velocity divided by time into length. Velocity is equal to length by time into length. That is equal to ML T power minus 2. LL is there. L square. ML square T power minus 2. This value I am taking. Hello?
Yes, sir.
So you need to go, if you don't know, you need to move from the unknown value to known value. Then only you will get the values, everything. You should not by heart these values. If you want to by heart, means your brain will damage. Okay, na? You need to go to the fundamental rule. Fundamental rule means basic formula to basic fundamental physical quantity. Na? We need to write up to fundamental physical quantity the same formula. Then this value is equal to, dimension formula is equal to ml square T power minus 2 divided by T, temperature in SI, temperature unit, dimensional formula Kelvin. Na? So that is equal to ml square T power minus 2 K power minus 1. K power minus 1. This is the dimensional formula for this one. So now one more method I am recalling this one. Let me use it as the out of syllabus, but they may ask in your examination. So what is the PV is equal to capital RT? It is for one mole equation. PV is equal to nRT. It is the n mole equation. This is the equation for n mole of gas. You already know this one. N is equal to number of moles. How can we get? Mass of the gas divided by molecular weight of the gas, na? So number of moles is nothing but mass of the gas divided by molecular weight of the gas. Molecular weight of the gas. So if we take the mass of the gas is equal to m, molecular weight of the gas is equal to capital M. Let me take like this. Then instead of m, can we substitute small m by capital M? No issue, na? Just I am substituting mass of the gas divided by molecular weight of the gas instead of n. Then the same equation can be written as a small m by capital M. Instead of m, I substituted into capital RT. This is also ideal gas equation only, but in terms of in terms of mass of the substance and molecular weight of the substance for n mole of gas. So that means if the substance of the mass of the gas is equal to 1 kilogram, if the molecular weight of the gas is equal to some, they will give. So hydrogen molecular weight and helium molecular weight, carbon dioxide molecular weight, like that they will give. We need to use this formula. Is there any issue? No issue, na? Then one more formula I am going to. Now they may ask. We need to know. This is here the out of syllabus is over about this one. They may ask for the specific gas constant. Specific gas constant. They may ask this one also. It will denoted with the small r. It is not gamma. Let me take small r. They will use small r. So what is the specific gas constant means? Let me give the mathematical expression. After that I will give the definition. Small r is equal to capital R divided by m. This is the specific gas constant value. How can we define? It is nothing but the universal gas constant per unit mass. That is the definition. So it is the defined that the universal gas constant per unit mass is named as the specific gas constant smaller. It is denoted with the smaller. Otherwise, they may ask the universal ideal gas equation for in terms of the specific gas constant. Just we need to substitute the value instead of r, we need to substitute the equation in terms of small r. So what is the formula? Small r is equal to capital R by small m. Then we can write capital R is equal to small r into m. So what is the ideal gas equation? PV is equal to capital small n RT. So then I am substituting instead of small capital R. Just we need to substitute this value small n into small r into small m into RT. This is the equation for the ideal gas equation in terms of specific gas constant. Are you getting or not? Hello?
Number of moles
If we take the one, this is the equation for n mole of gas. If you take the 1 mole of gas means PV is equal to small r m into T. It is the for 1 mole of gas. 1 mole of gas. No issue na? Hello?
Yes.
Now they may ask the question, what is the units of the specific gas constant? Specific gas constant. Units for specific gas constant. So that is equal to small r units. They may ask the question. So small r, if you want to write the units means you need to go to the basic fundamental formula. So small r is equal to capital R by m. R units you already know na. R units what are the units? Joule per Kelvin. So divided by mass units is equal to kilogram. Then can I write is joule per kilogram per Kelvin. Otherwise joule kilogram inverse Kelvin inverse. Kelvin inverse. That is the units only. If it is the SI units, these are the SI units. If we go to the CGS units, erg per gram inverse centigrade inverse Celsius inverse. Okay, that is the units. Now they may ask the question for what is the dimensional formula for specific gas constant. Dimensional formula for specific gas constant for small r, that means specific gas constant. You already know the dimensional formula for universal gas constant. Small r is equal to capital R by small m. Universal gas constant is equal to m L square T power minus 2 K power minus 1. This is the r units, r dimensional formula. Mass dimensional formula is equal to m only. M cancel. Then r dimensional formula is equal to m0 L T square T power minus 2 K power minus 1. This is the dimensional formula for specific gas constant. No issue na? So they may ask the question, what we are going to discuss now. You feel that let it take at the out of syllabus only, but it is the more important for the problem solving. So I am taking it is the out of syllabus constant what we are going to discuss now, but it is a very important for problems. So important for problem solving concept. It is a very important, but as per content they won't ask in your examination. That is you need to take care about this one. Please try to understand what I am going to tell. So they may ask the ideal gas equation in terms of Boltzmann constant. So ideal gas equation in terms of Boltzmann constant. They may ask Boltzmann constant. They will denote it with the capital K. What is the relation between the capital K and ideal gas equation? Capital R means we have the relation capital K is equal to capital R divided by N. N is the number of N is the Avogadro number. Here is the N is equal to Avogadro number. Avogadro number, you already know this one, 6.023 into 10 to the power of 23 atoms or ions or molecules per mole. for atoms or ions or molecules per mole. This is the constant value. Then they are asking ideal gas equation in terms of Boltzmann constant. So we need to remodify this equation in terms of R is equal to K into N. So basic formula where it is there, PV is equal to capital RT formula is there. Just I am substituting this formula where PV is equal to K capital N into RT. This is the basic. This is the formula for the ideal gas equation in terms of Boltzmann constant. K into N into T. This is the formula.
Sir, and 1 mole here, sir.
Yeah, this is the only for 1 mole. For 1 mole. If you take the N mole means PV is equal to small n into K into N into T. This is the N mole of gas. So this is the formula for N mole of gas, ideal gas equation. So they may ask the question in terms of density also. In terms of density also they may ask the question. So if we take the density already derived, na? Ideal gas equation density terms we already derived, na? Let me go to the top.
No, sir.
No, we did not derive.
No, sir, density.
Let me do here itself. PV is equal to RT. So I am going to this side. This side I am going. So ideal gas equation in terms of density. Ideal gas equation in terms of density. Density rho. So we know the density basic formula, fundamental formula. What is the basic formula for density? Density rho is equal to mass by volume. Mass by volume. So but in the ideal gas equation we don't having the mass term, but we have the mass term, volume term. Already we know, na? Hello.
Yes, sir.
Wait. Something is instructing here. Wait. Something is not responding. Board is not responding. Let me. Yes. Yes, here density is equal to mass by volume, but in the ideal gas equation if you recall the formula PV is equal to nRT is there, but we don't have any mass term, but we have the volume term. So I am writing this equation in terms of volume. V is equal to mass by volume. Then how can we write ideal gas equation? Capital P into mass by here I written wrong. Mass by density into nRT is there. So nRT is there. This is the ideal gas equation in terms of density. So Pm divided by rho is equal to nRT. This is the formula in terms of the density. No issue, na? Just I am substituted the equation in terms of general density formula. Just density formula I substituted. So the same formula, if we bring this one, the same formula I am taking this term in the Boltzmann constant also. Boltzmann constant term also I am taking. Let me go to here. Boltzmann constant, where it is? Yes, here is the Boltzmann constant. Instead of E, what we can write? Instead of E, what we can write?
Mass by density.
Yes, PV is equal to mass by density into N into K into capital N into T. This is the formula for this one. Here M is equal to mass. Here is M is equal to mass, but M is equal to mass. N into KT. N into KT. This is the formula. They may ask the question. Now another formula is there. Do you know the formula for molar mass and Avogadro number? Relation between the molar mass and Avogadro number? Do you know the relation? Relation between molar mass and Avogadro number. What is the relation between molar mass and Avogadro number to normal mass? So mass M is equal to molar mass into Avogadro number. It is the mass M is equal to molar mass. It is the real mass, that is equal to 1 kilogram mass is equal to how much molar mass is there into Avogadro number. This is the formula. If you don't know, means leave it. If we are going to the out of syllabus only, na, just leave it, don't worry about this one. Just I am going to substitute here. So mass of the substance is equal to, let me don't worry, if you don't know also, don't worry. So mass of the substance is equal to molar mass into Avogadro number. Avogadro number. This is the formula. So I am taking the mass of the substance m, molar mass of the substance I am taking m dash into Avogadro number is equal n. So instead of m I can substitute the m dash by n. Can I substitute now where it is in the top one? So what is the formula? Boltzmann constant in terms of density. Pm divided by rho is equal to, this is the Pm is equal to rho is equal to small n into k into capital N into T. This is the formula, na?
Yes, sir.
Let me check.
Yes, sir.
K and T. This is only, na? Okay. Now, this is the formula. In terms of somebody raised. What is the doubt, please, ma? Rogina. No. What I am taking. So I am planning to derive the equation in terms of the molar mass. I am planning to express this equation in terms of molar mass. So where mass term is there, I need to write molar mass into Avogadro number. Then P into, no issue, na? Hello? Then P is equal to m dash into n divided by rho. Rho is equal to nkn into T is there. So what we can do, cancel, n will cancel, that is equal to P into m dash divided by rho is equal to nkt. This is the formula, ideal gas equation in terms of the molar mass and Boltzmann constant. If this equation is taken in the 1 mole gas, for 1 mole gas, I am taking 1 mole gas means P m dash divided by rho is equal to kt. This is the ideal gas equation in terms of molar mass and Boltzmann constant terms only. Let me take the values of the Boltzmann constant and ideal gas constant. Those are the very, very important for your problem solving method. So the values, R values, I am taking R values is equal to 8.314 joule per mole Kelvin. This is the formula for that one. So this is 8.314. If you take the in CGS system 8.314 into 10 to the power of 7 erg per mole Kelvin. This is the R value in terms of erg per mole Kelvin. So this is the R value. Now if we go to the Boltzmann constant value K is equal to, let me bring this one, Boltzmann constant from the Google. Let me bring this one from the Google. Somewhere I searched this one. I forgot that one. Maybe 10 to the power of minus 23. That value is, I know the value, 10 to the power of 23. Boltzmann constant. Yes. 10 to the power of minus 23. Yes. 1.38. 1.38 into 10 to the power of 23. 1.38 into 10 to the power of minus 23 meter square, and the units are meter square kilogram per second square Kelvin inverse. Meter square kilogram per second square Kelvin. So you can get these units with the help of the derivation of the equation. Can I do this one? Let me do this one. How can you do this one? So what is the relation between R and any one of the relation you can go through. So where K is equal to R by N. Na?
Yes, sir.
Otherwise we will move with from which place we will go this one, meter square kilogram per second square. Okay. Let me from which place we will start this one to get this one. Just I am concentrating how can we justify these units, that is I am concentrating. Okay, you are saying that capital K is equal to R by N, but N units is equal to n units atoms per moles, but here is the atoms per moles. So what is the units of R? Tell me, will you please give the units of R? Joule per Kelvin, na? Okay, now I am going here. Joule per Kelvin in what? Joule per Kelvin divided by moles. Per moles, just per moles it is. So now, but here is the moles is there, ma. Moles term is not appear here. Are you getting or not?
Yes, sir.
Moles term not appearing.
మాస్టర్ ఉంది సార్
Mass term is there.
జోల్స్ ని కన్వర్ట్ చేస్తే వస్తుంది
Wait. Moles should be converted into mass. Moles means what is the number of moles formula? Number of moles means 1 mole is equal to mole. Mole is equal to mass per molecular weight of the molecular weight of this one. So molecular weight means this is equal to kilogram only. This is equal to kilogram only. Both will equal. They will cancel each other. This is just a number only. This is just a number. The bottom term always is a number. First we need to concentrate here. These terms only represent to this above relation. Now we need to go to the basic fundamental of this one. Here is the Kelvin is balanced, but joule we need to show this one. Joule is equal to meter square kilogram per second square. We need to show. We need to show that one. Okay, na? Let me show that one. Meter square. Meter square means a square kilogram. So what is the fundamental? Joule means it is the unit for energy. Na? Joule is equal to units of energy. Energy is nothing but work only. Na? Work is nothing but force into displacement. Na? Force is equal to mass into acceleration into length. So mass is equal to velocity by time into velocity time into length only. That is equal to mass into velocity is equal length by time into length only. So then how can we get this one? Then is equal to mass into L square divided by T square. So that mass means kilogram, length means meter square, time means second power minus 2. So we will substitute, everything is got, I think. Okay, na? Yes, it is balanced. Okay, na? Here is the per is there. Here per Kelvin, per second square per Kelvin is there. No issue, na?
Okay, sir.
Then, so everything is balanced. So like this, we need to go to the fundamental formula. Then only you can easily you will get the easily where. If you want to change any quantities to fundamental quantity, you need to go to the fundamental equation. Then only you can easily understand how it will be. Now we are going to write the equation. Very easy concept. But you need to use your brain. Small amount of brain you need to use. Then what is the concept is means variation of the density of the solid substance. How the density will vary with the temperature. So how the density will vary how the density will vary with the temperature. This is the concept of this one. They may ask in your problems. So generally these will ask in your problems, but directly concept they won't ask in our examination. That is the concept here. So before dealing this one, we need to get the basic concept of density. Density, what is the formula? Density is nothing but mass by volume. This is the formula. So mass by volume. So rho is equal to mass by volume. It is the formula is there. So what does it mean? So one thing you need to take care about this one. Mass is always constant. Always constant. That is a very important. If you want to bring 1 kilogram of mass from earth to moon means mass will not change, weight only will changes. Mass will always constant throughout the experiment. If we do not add the mass to the system, or if we not remove the mass of the system, that is the one important. That means let's assume for your easy understanding. So I kept here 1 kilogram mass here. I am performing the experiment on this 1 kilogram of mass. So mass won't changes. It will change the pressure, it will change the volume, it will change the temperature. Mass is always constant throughout the experiment what we are performing. But one important point is we need to take care. If you not remove the mass from the system, if you not add the mass to the system, then only this mass will be constant. Are you getting or not? So that is a very important point you need to know. Now, my question is, my goal is how the density will vary. How the density relation will changes with respect to the temperature. That is our goal. So to get this one, I am taking the fundamental formula. Let's assume here is the one of the system is there. Let maybe here is the gas which having the with some piston. So the mass of the gas is equal to m mass is there. Let's assume the volume of the gas is equal to V1 at the temperature is equal to T1 at the pressure P1. So now I applied this on the system. The volume of the gas is changes due to the increment of the pressure. The volume is changes to V2. Mass must the temperature is the T2. Pressure is equal to P2. This is the question. But what I told you, mass always must be constant throughout the experiment. Now what does it mean? See, while I am performing this experiment, which parameters is changing? P1, V1, T1 is changing. Here is the P2, V2 and T2 is changing. But in these two experiments, one of the parameters they are in the constant, that is equal to M is equal to M only. Is it correct or not? Hello?
Yes, sir.
Are you getting now? Hello?
Yes, sir.
So that means M is equal to M. For your easy understand, M1 is equal to M2. You feel like that M1 and M2. But M1 is equal to M2. M1 is equal to M2 because of M is equal to M only. So I am taking the fundamental formula for mass means mass is equal to density by volume. So density of the substance ρ1 divided by, here I am taking the density of the substance ρ1. Here I am taking the density of the substance of the gas is equal to ρ2. So ρ1 by V1 is equal to ρ2 by V2. Is it correct only, no? Okay, sorry. Mass is equal to, mass is equal to density rho is equal to mass by volume. So mass is equal to rho into V. Sorry, I confused here. Let me clear this one. Okay, done. Then rho1 V1 is equal to rho2 V2. This is the relation. Keep it aside. I will use this one after some time. So you already come across with a volume coefficient of the gas, volume coefficient of the material, or volume coefficient of the gas. Gamma is equal to, what is the formula? V2 minus V1 divided by V1 into T2 minus T1. It is the gamma relation. So our goal is to find out these relation in terms of the density, but I am taking this one because of in this term volume terms are there. That's why I am taking this equation. Send this equation this side. Therefore V2 minus V1 is equal to gamma into V1 into T2 minus T1. This is the formula only, na? Correct only, na? Now our goal is to find out the V2 value. Therefore V1 plus gamma into V1 into T2 minus T1. This is the formula. I am taking out the V1 term, that is equal to 1 plus gamma into T2 minus T1. So here is the V2 terms is there. So will you please look on this above we need a V2 value. Shall we bring V2 value from the equation number 1? Let it be the equation number 1. So V2 is equal to, from this equation, rho1 V1 divided by rho2. We can get now. So I am substituting the V2 value in the equation number 2. So by substituting V2 value in equation number 1, equation number 2. So then how can you write rho 1 V1 by rho 1 V1 by rho 2 is equal to rho 1 V1 by rho 1, sorry, rho 2, sorry, 1 minute, let me see.
V1 by rho 2.
Rho 1 V1 divided by rho 2 is equal to V1 into 1 plus gamma into T2 minus T1. Is it correct only, na? So now V1 will cancel, then rho 1 is equal to rho 2 into 1 plus gamma into T2 minus T1. What is our goal? To find out the density, variation of the density with respect to the temperature. Just we can, if we know the density of the substance at a given temperature, we can easily find out the density of the substance in another temperature with the help of this formula. So I given that all gases, all substances, generally they will increase the value. They will increase the value while increasing the temperature. When the temperature is increases, volume will be increases. Only one specific materials are there, is the silver iodide and water. That is also one particular region only. The region of the water is equal to 0 degrees centigrade to 4 degrees Celsius. This region volume will decreases, and silver iodide is equal to 120 or 120 degrees centigrade to 140 degrees Celsius. Silver iodide is there. Only these two properties only they will decrease the volume. So remaining all materials generally they will increase the volume while increasing the temperature. But that means the all materials they will show the gamma value is the positive value. Gamma value is the positive value. So while volume is increases, general common sense I am applying, rho is equal to mass by volume. If the volume is increases, generally density must be decreases. Is it correct now?
Yes, sir.
So density must be decreases. Can I write this in terms of rho 2? This equation I am writing in terms of rho 2. Please write this equation in terms of rho 2. Rho 2 is equal to rho 1 divided by 1 plus gamma into T2 minus T1. So will you please look on this one. So while temperature is increases, this term is going to the more than plus 1, more than 1. So if it is this total term is going to the greater than 1, this rho 1 term, rho 2 term will going to the lesser than to the rho 1. Are you getting or not? So what I am telling here, once again I am repeating. So if gamma is the positive value, then bottom, so denominator term will get the 1 plus gamma into T2 minus T1 will get the greater than to the 1. If it is this total term is the greater than 1, then rho 2 term will lesser than to the rho 1. Rho 2 term is lesser than to the rho 1. So this is common sense. What we are applying the common sense is a balancing. When the volume will increases, when the temperature is increases, volume is increases, density must be decreases. Here is also density decreases, density is decreasing because of temperature rises. Are you getting or not?
Yes, sir.
So this is the basic formula for the how can we determine the density of the substance, how the density changes with respect to the temperature. Now we are going to the another small yes please.
సార్ సిల్వర్ అయోడైడ్ అన్నారు కదా సార్, ఏంటి సార్ అది వాల్యూమ్ తగ్గితే టెంపరేచర్ పెరుగుతుంది?
Yes, no, I already told that one. Silver iodide will show the peculiar property that while 120 degrees to 140 degrees centigrade, this value will be decreases. This volume will be decreases while temperature is increasing. So it is a reverse property showing. Water also will show the volume will be decreases. Volume will be decreases while temperature is increasing. Only in this region only. Only from 0 degrees Celsius to 4 degrees Celsius. Only 140 degrees Celsius to 120 degrees Celsius to 140 degrees Celsius. What you told, it is absolutely correct.
Yes, sir.
Done. Now we are going to the another important topic. In this topic, you need to write in your common words, in your general words in your examination. So you need to use your brain as much as big. So please ready to use your brain. Don't sit and ideal. So that is the why, because of this concept is a completely common sense concept. You need to use your brain. So the concept name is anomalous expansion of water. Anomalous expansion of water. So what does it mean, sir? So all materials, they are showing that one, while heating the all materials we should show they are increasing the value. All materials while heating they are showing that they shows volume will be increases. Volume will increases. Volume will increases. This is the case we are observing. But only the water is showing while we are heating from 0 degrees Celsius to 4 degrees Celsius, water is showing they are decreasing the volume. It is decreasing the volume. It is decreasing the volume. So this property is named as the anomalous expansion of the water. So anomalous expansion means so if we feel that why it is showing the expansion, that means it is increasing. So that is giving the in the reverse manner. So I will come into the reverse manner. So it is decreasing the volume, means if you cool the water from 4 degrees Celsius to 0 degrees Celsius, 4 degrees Celsius to 0 degrees centigrade, it is a cooling. We are cooling the water. So all substance will show that the volume will be decreases, but here the water volume will be increases. Water volume will be increasing the water volume. So that means here the anomalous expansion is showing, that is the water is showing the one particular property. So we don't know what is behind this one. So we up to our level we are not dealing with what is happening behind this one, what is going on, why the water is expanding. We are not dealing that topic. Just we are using the application of the anomalous expansion of the water. So water, while coming to the 4 degrees Celsius to 0 degrees centigrade, the water volume is increasing. Volume is increasing. This is the very important volume. Volume is increasing in this region. So how can we, what is the, how can we say this one? One of the scientists, he did some of the experiment with, his scientist name is Hope. Hope is the scientist name. So he introduced one of the apparatus, Hope, introduced the operator to find out the anomalous expansion of the water. So each operator name is the Hope apparatus. Hope's apparatus. So with the help of the Hope's operator, we can easily find out we can easily recognize the anomalous expansion of the water. Is a very small apparatus only. It will consisting of one of the vessel which will having the water. They will consisting of water. So they will have the readings on the water to find out the what is the temperature of the water. They will use the temperature thermometer in this vessel. We can easily recognize what is the temperature of the water in the vessel. So in the they will use the one of the extra vessel. In this vessel they will use for freezing they will use the some of the materials. They will ice bricks or something. They will use the ice bricks to cool the water up to 0 degrees Celsius. This is a small apparatus only, but to get this apparatus to your normal laboratory, only problem is there. We need to bring the ice pieces. That is the only problem. To prepare the ice pieces, at least we need to have the one small refrigerator. That is the basic problem to introduce this experiment in your laboratory. But it is a small experiment only. So with help of this one, they will use the readings. So how the readings is varying while cooling the water, whether the volume is increasing or decreasing. Just they will take the readings. Then only they will easily say that how the water level is increasing or decreasing with the help of this one. So that is a small experiment, small apparatus. So now, while performing this experiment, the Hope is measured the density of the water. So I am taking the Hope, what are the readings which is measured by the Hope from the 0 degrees centigrade to at least 10 degrees Celsius. I am going to give this one. This is the values which are measured by the Hope. So I am taking the temperature value in degrees Celsius, and what are the density of the water in gram per centimeter cube. Cc means centimeter cube. So the Hope is measured at 0 degrees Celsius. the density of the water, they observed that 0.99987 degree gram per cc they observed. So at 2 degrees Celsius, 2 degrees Celsius I already given here, no need to write again here. So at 2 degrees Celsius the value of this one 0.993497, it is a gram per cc. At 4 degrees Celsius the value of this one he observed that 1 gram per cc he observed that one. If we go to the further, if we go to the 6 degrees Celsius, the value of this one he observed that 0.497 he observed that, and 8 degrees Celsius he observed that 0.99988 he observed that. At 10 degrees Celsius the value of this one is equal to 0.9973. So no need to by heart these values, just I introduce this one, these values only for draw the graph, that's only I introduce, no need to by heart for your examination. You can directly draw the diagram in your examination. So if you take the if you draw the diagram by taking the temperature in the x scale, and if you take the density in the y scale, density in gram per cc, how it look like? I am starting the experiment from 0 degrees Celsius. Now it is the temperature is 1 degree Celsius, 2 degrees Celsius, 3 degrees Celsius, 4, 5, 6 and 7 and 8, like that I am moving. This is the temperature of the scale. So the density, will you please look on this one? It is the temperature, it is the density at 0 degrees, it is the density at 2 degrees, it is the density at 4 degrees, it is the density at 6 degrees, 8 degrees, 10 degrees. So will you please look on this one? The density is increasing in this region. Are you getting or not? Will you please look on these values? See 0.99987, 497, 1. That means in this region the temperature, the density is increasing. So if we start from 0 degrees, that some value of the density, let maybe I am taking some 0.33987. It is a 0 degree centigrade. So this value is increasing up to which value? At 4 degrees Celsius, this value is increasing. So let me take this draw. Let me draw once again this diagram. So from this value is increasing up to 4 degrees Celsius. So it is a 4 degrees Celsius. After this value, will you please look on this one? 978873, like this. Again it is decreasing its density. Are you getting or not? Hello? Are you getting or not? Will you please reply? Otherwise I will repeat once again. So just I am taking the values of the density which are measured by the scientist of Hope. Hope is measured these densities in the different temperatures. So he observed that these values are, if we just look on this table, so here is the 87 is there, here is the 97 we got, increment is there. So it is increasing the density. If we go to the 1, it is increased. After this, it is decreasing. Arrow is showing downward direction is decreasing. Arrow showing in upward direction is increasing. Just I am drawing the graphical representation how the density and the temperature is, how the density is related to the temperature. At the 0 degree centigrade, the temperature, the density of the water is 99987. If we go to the up to 4 degrees centigrade, the density is increasing. That's why I increase up to 4 degrees centigrade. That maximum value of this value is equal to 1 gram per cc. After this, the temperature is increasing, the density is going to down. After this, that normal it is showing. If you use the common sense also, you can easily say this one. Common sense, how can you use common sense? What is the basic formula for density?
Mass by volume.
Tell me the density basic formula. Let me use this one. Density basic formula. Density is equal to mass by volume. So from where we are coming? From 0 to 4 degrees we are coming. So generally 0 to 4 degrees volume should be increases. We are going to from 0 degrees Celsius to 4 degrees Celsius. We are going mass is always constant. So generally from 0 to 4 degrees Celsius we are moving. We will expect that volume will increases. But water is showing the peculiar behavior. Volume is decreasing. Are you getting or not? Hello? Hello.
Sir, increase అవుతుంది సార్ దాంట్లో.
No. We are moving from 0 degree centigrade to 4 degree centigrade.
Yes, sir. Yes, sir.
That is the very important. So that means volume is decreasing. While volume is decreasing, this term is decreasing means this denominator term is decreasing means density will rise as increasing.
Right.
Are you getting or not? Hello. That's why I told you before start this lecture. I told you please use your brain. Don't sit on an ideal manner. Please use your brain. So if you just a little bit brain only we are applying here. Don't we are not using much more brain. So that means while we are moving the temperature, while we are moving temperature from 0 degree centigrade to 4 degree centigrade, density is rising. So increasing in density. After 4 degrees Celsius, density again it is decreasing. Again it is decreasing. It is going some value. So in the same manner. In the similar manner, if we draw the graphical representation between the volume and temperature, anyone will tell this one volume and temperature diagram. Anyone. So let's assume it is the 0 degree Celsius, it is the 1 degree Celsius, it is 2 degree Celsius, it is the 3 degree Celsius, 4 degree Celsius, 5 degree Celsius and 6 and 7. I already told you water is showing the peculiar behavior. While we move from 0 degree Celsius to 4 degree Celsius, we will decrease the volume. Volume will decrease us. That means if we start the volume some constant value volume, so that means the graph will come down. Up to which value? 4 degrees Celsius. After 4 degrees Celsius again the volume will increases. Are you getting or not? Hello. So that is let's assume this point is the 4 degrees Celsius. Due to I drawn some wrong, so that is it is the 4 degrees Celsius. This is the graphical representation for the how the volume will changes with respect to the temperature of the water. How the density will changes with respect to the temperature of the water, varying the temperature of the water. So now what is the application of the what is the use of the anomalous behavior of the water? Use of anomalous expansion of water. I am requesting you, please use your brain once again. This is not a normal topic. You need to use your brain, then only you can easily understand. See, I am starting with this one. How the anomalous behavior of the water will use us in your nature means. Let's assume I am taking the one pond or one river. This is a very depth river. Let's assume take a very depth river like this. It is the water which is having in this river. So in the winter season, the lake, the temperature of the total surroundings will decreases. So the temperature is going to decrease. Now I am not taking the complete temperature decreasing. Just I am starting from 4 degrees Celsius to temperature is decreasing from 0 degrees Celsius. This condition only I am taking. I am not discussing from about this temperature. Will you please look on this one? Where 4 degrees Celsius to 0 degrees Celsius. See, before this decreasing, the water is consisting of all water is having the same 4 degrees Celsius. Here is the water is the everything is the 4 degrees Celsius. So let me introduce one more concept before you to improve to activate your brain. Let me use this one. So now I take the two types of liquids. Two are in the two different densities. So let's assume I am taking the density D1, another one is the density 2. So which one will float on the another substance? Now I am taking the relation. So D1, see now I am taking this one. This is the liquid which is having the one of the density. This is the liquid which is having another density. To float this D2 liquid on the D1 liquid, it is the liquid 1, it is the liquid 2. To float the liquid 2 on the liquid 1, what is the relation between the densities of these two liquids? D1 must be lesser than to the D2. Are you getting or not? So that means the oil is floating because of it is having the lower density as compared to the water. So because of that is the liquid which is having the now I am giving the conclusion. So if the liquid having the more density, it will go to the bottom surface of the layers. Is it correct only, no?
Yes, sir.
Is it correct only, no? That is condition is correct only, no? Please keep it in your mind. So if the more density particle will stag into the bottom surface, that is the very important. It will stay on the bottom surface. That is the very important. Now I am going to this concept. Now, where if it is the general case, the total lake is at 4 degrees Celsius. Now it is decreasing its temperature. While it is decreasing, what will happen? What will happen while it is decreasing means we already very familiar. Volume will be increase or decrease?
Increases. Increase, sir.
Yes, volume will increase. Volume will increase. While volume is increasing, density will.
Decreases.
Oh shit. Volume will increase. Volume will increase means density will.
Decreases, sir.
Wait, density will decrease, na?
Yes, sir.
Density will decrease, volume will increasing, or density will increases. Yes, density will increases. So volume is increasing, density will decreases. Density will decreases. Density, yes, density will decreases. So that means density will decreases. So I am taking rho is equal to mass by volume. Mass by volume means now when we are coming to from 4 degrees Celsius to 4 degrees Celsius to 0 degrees Celsius, then the density, the volume is increasing, density will decreases. Okay, na? Density will decreases. That means volume will increases, density will decreases. No. Let me start with 10 degrees Celsius. Let me start from 10 degrees Celsius. Let me start with 10 degrees Celsius. So 10 degrees Celsius. Please keep it in our mind. We have started with 10 degrees Celsius. First of all, we are assuming that the lake is at 10 degrees Celsius. From 10 degrees Celsius to 4 degrees centigrade, what can we observe? Water is showing as a normal behavior of the how the all substance will showing the same behavior also the water also showing. That means if you are coming from 4 degrees Celsius to 10 degrees Celsius to 4 degrees Celsius, volume will decreases. Volume will decreases. Are you getting or not?
Yes, sir.
Volume will decreases. While volume is decreases, the density formula rho is equal to mass by volume. So volume is decreases, density will also decreases. Density will increases. Density will increases. Density will increases. That means up to 4 degrees Celsius. Up to 4 degrees Celsius, what is happening? So the top layer of the liquid is going to the bottom surface of the river. Is it correct only, no?
Yes, sir.
Hello, use your brain once again I am repeating. So while we are coming from the 10 degrees Celsius to up to 4 degrees Celsius, the density of the liquid which is cooling up to 4 degrees Celsius, the top surface of the liquid which is cooling, they are going to the bottom surface because of they are having the more density.
Yes, sir.
They are going to the bottom surface of the river. So they are going to the bottom up to 4 degrees centigrade. The liquid is allowing going to the bottom surface. Is it correct only, na?
Yes, sir.
So that means this is the 4 degrees centigrade river. So that means here is the 4 degrees centigrade God, here is the 4 degrees centigrade. Now we are concentrating what is happening from 4 degrees centigrade to 0 degrees centigrade. Now another case we reached. Case 2, the stage 2. Liquid is we are discussing in the liquid stage 2. From 4 degrees centigrade to 0 degrees centigrade, water volume is increasing. That's why the density will decreases. Density will decrease. That means the water level is cooling here. The water is cooling here due to the atmospheric temperature, the surrounding temperature. This is cooling. While it is cooling, the density is decreasing. It won't allow go to the bottom surface. It need to stay on the same top surface only. Are you getting or not?
Yes, sir.
It is a very important point what we are discussing now. So what is saying, while the water is cooling from the 4 degrees centigrade to 0 degrees centigrade, as the density of water is decreasing, the liquid, the lake, the river water, they won't allow go to the bottom surface of the river. It must be stay on the top surface of the river itself. Is it correct? My statement is correct or not?
Yes, sir.
So that means the river top layer only it will cool down. The river top layer only it will cool down. So up to 0 degree centigrade. So up to 0 degree centigrade means water will cool up to 0 degree centigrade only. After the 0 degree centigrade, water will act as a ice. It is formed as ice. It is formed as ice. That means only we can observe the ice layer on the top surface of the river. The bottom surface of the river, it will act as a water itself. Is it correct only now? So what is the hello? Hello. You may ask the question. If the further is decreasing, what will happen about this lake? You may get the doubt. So that means some more layers of the top surface of the river will convert into the solid ice peaks like this. So what I am saying, the river will cool down from the top surface of the layer. The river is cooling down from the top surface of the layer. If you are supplying the more heat energy to the system, if you are supplying the more lowest temperature to the river, then it will cool down from the top surface. Top surface it is cooling, it is forming from the top surface. It is creating the solid layer from the top surface. It is the more advantage of the river. See, because of the winter season, they will consisting of maximum 4 to 6 months it will have it. So the river will having the more broad area. It will having the broad area. So the atmospheric low temperature is much not enough to cool down the total liquid layer which is consisting of the river liquid. That's why they will cool the river layer up to certain region only. Are you getting or not? Hello?
Sir, ఒకవేళ రివర్ మొత్తం ఐస్ అవ్వాలంటే సార్
we need to supply more lowest energy to the river. It will how it is forming in the poles, at the poles of the earth poles is there na, earth poles. We need to supply as much as low temperature to the river, then only it will freeze the complete liquid of the river.
Yes, sir.
It is not happening. It is not happening on this one. So what is happening? If you are supplying the more lowest temperature to the river surface, then the river layer will come getting the freezing from the top surface one by one layer. It is freezing. But we are having the winter season maximum 4 to 6 months. That's why maximum the river layer will get the maximum up to certain layer only it will come. So the water will exist in the bottom surface of the freezing point of the freezing levels or layers of the river. That means you may get the doubt, what is the advantage of this one? Water is existing, why are you teaching this of the nonsense? You may get doubt. But one of the greatest advantage is there. So river is not a normal river, it is a world. It is consisting of world with consisting of more sea species, sea lives. That means it will consisting of it may be fishes, it may be crocodiles, it may be crabs, it may be frogs, it may be like any. It consisting of it is a broad and it is a life cycle is there here in this river. Are you getting or not? So the river consisting of a big life cycle is there. Are you getting or not? Hello? Hello?
Yes,
so what I am saying, the river consisting of big life cycle which is having in the water. So if this total river is a frozen, then the total lives of these which are depending on the water, they may die. So they may die means the total life cycle of these these animals or these water species, they won't exist after this winter season completed. So that means every winter season, the insects or the animals which are living in the water, they are clearly living because of water anomalous expansion of the property. Because of they are having the life, they are existing the life because of water is existed. bottom surface of the river, they can easily move around this water. They can easily they can easily take the oxygen from the water because of the lives which are depending on the water. They can easily take the oxygen from the water because of water consisting of H2O. They are consisting of water from the H2O. They can easily take from the water. So that means what I am taking. So it is the created by the God. So they we don't know, it may be God or nature. It is created by the nature. So because of nature only, it is created to get the life of the animals which are depending on the water. So they can easily continue their lives. Even the top layer of the water is frozen, because of it is not possible to freeze the total entire water of the pond, entire water of the river, entire water of the sea. We cannot freeze, because of it is unable to supply that much energy to this one. It is the lowest energy, we are unable to supply that much lowest energy to the river. That's why the normal animals which are depending on the water, they are existing their lives even at 4 to 6 months. Even the top layer of the river is frozen. It is the very useful advantage of the anomalous expansion of the water. That's why you can see this one. One more example I need to say here. One more example I need to say here. Will you please look on this one? Ice is floating on the water. Ice is floating on that water because of ice.
Is less than what?
Ice. It is a very important question also. Ice density is lesser than to the normal water density. That's why ice always float on the water. Are you getting or not? Hello. See, ice density will always, density of the ice is always lesser than to the density of the water. That's why ice is floating on the water. Because of, you will please look on this one. See, here is the density is high. Bottom surface water is the density is high. If we go to this cycle, density is lower. So that ice is forming in this step. In this region only ice is forming. So here is the lesser density ice is forming. Bottom surface water is existing the more density. That's why ice always float on the water. Hello? Hello.
Yes, sir.
So that is the advantage of water. Can I draw the diagram how the river will look like? So how can I draw the diagram, temperature diagram, how the river look like? So the river look like, here is the here is the 0 degree Celsius ice will exist, which is having lower density will exist. After that, if we go to the downward, 1 degree Celsius will exist, 1 degree centigrade water will exist. If we go to the 2 degree Celsius, water will exist. If we go to the 3 degree Celsius, water will exist. Remaining all 4 degree Celsius water will exist.
Sir, maths sir join అయ్యారు.
Okay, then thank you. Let me close here. Thank you, Bala. Bye, all of you. We will discuss later. Thank you.
Okay, sir. Thank